Hey there. So welcome to another video on math problem solving. My name is Bharat Divyan from Zugzwang Academy. Now I saw this post on Facebook which said that the date, which was the 1st of May this year, to have a very specific mathematical form of 5 power 0, 5 power 1 and 5 squared. So it got me thinking, when would the next such date be and when would the last date in this century be? Okay, so that's today's question. When is the next date going to be and when is the last such pattern date in this century going to be? So you can pause the video and try to solve it. All right, so I hope you were able to find a couple of answers. So let's look at this. Now, if you see this particular pattern at an abstract level, it's nothing but b power 0, b power 1 and b power 2. So b being 5 gives you this particular date. Okay, we're still talking dd, mm, yy. So which means think of it as m being something that can go from 1 till 12 because that's the 12th month. So what are such patterns that's possible? Now, if you look at this, obviously the base is 5, so the next one is going to be 6. So it would be 6 power 0, 6 power 1 and 6 squared, making the date 1, 6, 36. So that's about 11 years away from now. So this would be the next one. What about the last one? The last one, as you can imagine, is going to be defined by the last perfect square less than 100. And as you can see, it's 9. So it's 9 power 0, which is 1981. So in 2081, we're going to be seeing that last date. And you can't count 100 unless, if you make that exception, then you could probably say the 1st of October 2100 is also going to be there, but it's a little tricky to accept this format because you're eliminating only 2 and leaving the other. So in a pure form, I would say this would be the last and this would be the next. How many such dates would be possible? And as you can see, you can start from 1 all the way till 9. So in a century, you would have 9 such dates. Okay, but what if you make an exception? What if you say, hey, let the format be b power 1, b power 2, b power 3. In other words, continuous powers, right? So in that case, what happens? So now you know that b squared is going to be the defining constraint, which means the month has to be between 1 to 12. And what are the bases for which the square value stays here? So as you can see, if the base is 2, then b squared is 4, which works. If the base is 3, b squared is 9, which works. If the base is 4, it doesn't work. So it's only for these two values. So if I look at it from this perspective and I substitute the value 3, then it would be 3rd of September 2027. Right? So in its pure form of exactly following this pattern, the next date is going to be this. But if you make a little bit of a leeway, a change, and say it's B1, B2, and B3, then the next date is just 2 years away where we might see it. And it also happens to be the last such date because it might not work for the value 4 because it becomes 16, the month 16, and it doesn't work. Now, it's a whole different ball game if you follow the American system of month first, date next, and the year last. Now, that is an explorative math project that you should be able to do this summer and think about how many such pattern dates that you can see following the American system. I hope you like this video, and if so, please do like, share, and subscribe, and I'll see you in the next one.